We good? All right, Fetchers of America, welcome back. I got a couple extra helpers today. Come on to this side of the camera. This is Jordan, the master soccer player, and Hallie, the prettiest girl on earth. These are my youngest two. Go for it, guys. They are running the camera today. Nicole has better things to do. She's working out. That's right, here we are. In our what is it? What are we, some kind of new order, stay-at-home order? What is it called? You know? I don't know, man. We're under martial law here in Idaho. That's all I can tell you. Last time that we met, I gave you two problems to do at the end of your 5.2 assignment. The two problems I gave you, this was one of them. And the thing that we identified was that this number here wasn't 1. Let's all of us right now, let's pause. You guys are okay, you don't need to pause. We're going to pause. You guys are going to pause at home on your cameras. And I want you to write the 5 methods of factoring and the type of polynomial they are possible on. Go ahead, guys, hit pause. All right, so you wrote those down. I did too. Let's take a look here. So our first method of factoring is common factor, then grouping, then the x squared plus bx plus c, where a equals 1. Okay, we did these in section 5.1. We did this one in section 5.2. Today we're going to do this. This will be 5.3, and this will be 5.5. You say, what happened to 5.4? We're going to talk about that in a little bit, okay? Later on today. All right, the possible polynomials, each of these is possible on all 4 terms, 3 terms, 3 terms, and binomials, okay? Make sure that you've got that memorized. All right, so we're going to look at this first polynomial that we gave you as one of your final 2 problems in your homework from section 5.2. 4x squared minus 17x plus 15. First thing I want you to do in this process is to check for a common factor. This is divisible by 2. Is that? No. Is that? No. Okay, so we do not have a numerical common factor. X. Do I have an x? No. So I do not have a common fetcha. Okay? Factoring by grouping. Is factoring by grouping possible? I have to have 4 terms, okay? I have 1, 2, 3 terms up here, so factoring by grouping is not possible. I have a trinomial. Which method am I going to use? 3 or 4? Well, that depends on what a equals. And if you remember, a, b, and c are the coefficients or the big numbers of each term. Do you guys know what a equals in this one? Do you know?
4.
4. Good job, Jordan. Do you know what b equals?
17. Negative 17.
Negative 17. Good job. Way to catch yourselves. And what does c equal?
15.
15. Good job. All right. All right. So Hallie and Jordan know what a, b, and c are. Did you know what a, b, and c are? I hope so. So tell me something. Does a equal 1, everybody? Does a equal 1?
No.
No. It equals 4. Okay? And so since this doesn't equal 1, we cannot use method 3. We have to use method 4. Well, we didn't know method 4 last time. We only knew method 3. So what did you do? How did you do this problem? I would be really interested to know what you came up with. But since you are in the virtual world with me, and some of you say, why don't we Zoom? Well, we can't do everything, but we're going to try. Maybe, if we got time. Next week's kind of the last week of school, and then a day or so after that for some tests, but check it out. So if you tried to, find c and say c equals 15 and factor it and said, b equals negative 17 like we do in our other stuff, and you're like, well, 15 and 1 makes 16, and negative 15 and negative 1, that makes negative 16, and you tried others like 5 and 3, and that makes 8, negative 5, negative 3, and that makes negative 8. None of them make negative 17, and maybe you said prime. Guess what? That answer is wrong, okay? It's not prime, all right? This is totally a factorable polynomial. So if you did this at home, you didn't get it right. But I told you I would give you credit for your work, okay? I told you for trying, I would give you credit on these 2 problems. So it didn't matter if you got them right or wrong, these last 2. The others you needed to get right in section 5.2, but these 2, you're okay. So check it out. Here's the thing. Do you know when we have like x squared minus 5x plus 6, and we factor that, how did we know what this term and this term needed to be? They both needed to be x and x because when multiplied they had to make x squared. So let's think about this. If I have a parentheses and a parentheses, and when multiplied together they have to make this, what does this and this have to be? Well, it can't just be x and x makes x squared. It would have to be like 4x and x to make 4x squared, or it could be 2x and 2x to make 4x squared. You guys agree with that? Yeah, totally, okay? And then here's the thing. This method that I'm going to show you right now, it's called the trial and error method. Okay? Trial and error method. All right? So, let's come back to this one. There were two things when multiplied together needed to make 6. When added together needed to make -5. And so we said C equals 6 and B equals -5. Can you guys all see me in the camera? Camera people?
Yeah.
Oh, good, good. Okay, and so then we said, like, what about, 6 times 1? That makes 6. But 6 plus 1, when added together, it makes 7. I'll show you something interesting here, okay? If I had, say, 6 and 1, you all agree with me, x times x makes x squared, and 6 times 1 makes 6. The question is, what are we making in the middle? So x times x, like we said, makes x squared, and x times 1 makes plus 1x, and 6 times x makes plus 6x, and 6 times 1 makes plus 6. And so these combine to make 7x. Look at this, 7x. So what we were doing when we made this chart is we were avoiding using this trial and error method where we have to multiply the binomial times the binomial to find out this is wrong. We just add this to find it's wrong. So we eventually try like -3 and -2, right? And we find that does make -5. So we can take x, -3 times x minus 2. But what I want you to see, and I hope you're following because I'm teaching you a really important concept here. What I want you to see is that this term and this term, x and x, make x squared, right? X and x, okay? And then I also want you to see that 6 and 1 also make this term 6, okay? It's the middle term that we're trying to get right. So when we multiply this out, x times x makes x squared, x times -2 makes -2x, -3 times x makes -3x, and -3 times -2 makes +6, as it should. Because we know that x and x are going to make the first term, and -3 and -2 should make the last term, but it's the middle terms now. They combine to make -5x, and so this was the winner. And we did it with this method, but this method doesn't work when a does not equal 1. We need to learn a new method, okay? And we're going to learn that method today, but not quite yet. I need you to try and error first, okay? So bear with me, all of you. I need you to try and error. So I'm going to erase this stuff, okay? So just like we were trying to find out what two things when multiplied together make this term, I now want you to tell me, well, what two things when multiplied together make 15? So you guys, what are some numbers, Jordan and Hallie, what are some numbers when multiplied together make 15?
3 and 5.
3 and 5, okay? So if I say +3 and +5, we know that 4x times x will make 4x squared, and 3 times 5 will make 15. Are there other things when multiplied together make 15?
Yes.
What?
15 times 1.
Very good, 15 and 1, okay? And so things that make 15 are 3 and 5, and 15 and 1, and then they're negatives. -3 and -5, and -15 and -1. So what I want you all to understand out there in cyberspace for Math 100B today is that we could plug any of these into here and here, these two, these two, these two, these two, and they would make +15. So we try this and we see if it's right. And if it's right, we're done. We found the factors. If it's wrong, we've erred and we have to try again. So let's multiply this out. 4x times x makes 4x squared. 4x times 5 makes +20x. 3 times x makes +3x. And 3 times 5 makes +15. So we knew that the first term and the last term would be right. But the middle terms combine to make 23x. So is this right? No, it's not, because we needed to make -17x and it made 23x. And so we tried, we erred, okay? We could put that +3 and that +5 in there and try that. 2x times 2x makes 4x squared. 2x times 5 makes +10x. 3 times 2x makes +6x. And 3 times 5 makes +15. These combine to make 16x. Is this the same as that there? No, we tried, we erred again. Okay, do you like the trial and error method? Yes or no? No. You're all saying no at home. Yeah, this method totally bites, okay? Nobody digs it, all right? It's hard, it's a pain in the butt, okay? But what I want you to get, we're going to continue with this, is that you could, okay, so we tried 3 and 5 in both of these. So we checked that off, okay? Now, the next pair that we could try is 15 and 1, okay? So we could put, okay, why do we have these two different sets? Because these are the two sets we multiply together to make 4x squared. We don't know which one works. So we can put plus 15 and plus 1 here. We can multiply that out, okay? And let's go ahead and do it, okay? So 4x times x, everybody. Yeah, indeed, it makes 4x squared. And 4x times 1 makes plus 4x. And 15 times x makes plus 15x. And 15 times 1 makes plus 15. These two combined, they make 19x. Does this work? No, it doesn't work again. Okay, so it doesn't work on this one. So we plug it down here. Plus 15 plus 1. We multiply again. We get 4x squared plus 2x plus 30x plus 15. When you multiply them out, 15 times 2 is going to be 30x. 2x times 1 is plus the 2x. These combine to make 32x. Did this work? No, it still doesn't make that. And so what did we do? We tried 15 and 1. We erred on both of these. It didn't work. So we moved to the next one. Negative 3 and negative 5. Okay? So here we go. Negative 3 and negative 5. Let's try it again. Okay? Now you should all be doing this with me at home. Okay? So let's plug in negative 3 and negative 5 and negative 3 and negative 5. And what I want you guys to do at home right now is I want you to pause. Okay, you guys are cool, camera people, you guys are cool. I want you, in 5 seconds, I want you to pause this and I want you to multiply these two out and see if you come up with this, okay? So we're going to pretend pause. Oh, we're back. Good. So hopefully you paused. Did you come up with the right answer? Well, let's try this out. 4x times x, everybody, 4x squared. That's what you should have got. 4x times negative 5, negative 20x. Negative 3 times x is negative 3x, and negative 3 times negative 5 is positive 15. This makes negative 23x, and it did not work. I went fast because you already did this at home, so we know that is not the same as this. Now we multiply this. 2x times 2x makes 4x squared. 2x times negative 5 makes negative 10x. Yes? Okay? And negative 3 times 2x makes negative 6x. And negative 5 times negative 3 makes positive 15. And these combine to make negative 16x. All right. Man, we are close, but not close enough. Okay, let's pause for a second. You. All right. So you tried both of these and they didn't work. So one of the things that also makes the trial and error method really stink is that the order in which you put these in actually makes a difference, okay? Now I've taught you, please pay attention, that 4x minus 3 times x minus 5 also equals x minus 5 times 4x minus 3. But the thing that I do want you to understand is that this does not equal 4x minus 5 times x minus 3. If I just switch the numbers around here, that's going to yield a different answer. So right now, on your own, at home, I want you to take this exact same pair that we just figured out doesn't work, and I want you to rearrange them, okay, this time around, and I want you to say, all right, instead of negative 3 here, I want you to put it here. So we're going to have, okay, minus 5 and minus 3. So you can take these and rearrange them. Because we all agree, negative 5 and negative 3 will make positive 15. So we're going to do the same here, okay? Negative 5, whoop, negative 3. Okay, I want you to multiply those at home, okay? We're going to pretend pause over here. We're back. Okay, check it out. So, 4x times x is 4x squared. 4x times negative 3 is negative 12x. Negative 5 times x is negative 5x, and negative 5 times negative 3 is positive 15. And hopefully you didn't do this other one, because when you put these together, it makes negative 17x. And whoa, 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 it's magic. This is our answer to this problem. How many of you, in your homework, got this right before we did this today? Okay? Say woo. Woo! Okay? So, check it out. I want to take just a minute and I want to tell you guys a little story about something. How many of you, when you were in high school, ever pulled into the parking lot and as you pulled in there, there was some kid that pulled in their BMW or, you know, their little Porsche or some fancy car like that, okay? Maybe it was you that did that, okay? So I'll ask you this question. What did you think about that person that pulled into the parking lot with that fancy car, okay? Were you jealous? Did you think they were spoiled? At the end of the day, you probably thought they didn't earn it. So one of the things I want you guys to understand today is that in high school and junior high school, we teach students the trial and error method to factor trinomials where a does not equal 1. But there's a better method, okay? And kind of like that kid in school, we want you to earn this method. If you've never done the trial and error method before, then when I teach you the new method, you're like, oh, this sucks. When I was in high school, I had a really good friend, and he had a fancy sports car, and his parents were wealthy. And anyways, we would drive around town, and he had a big boom box, and we would be thumping and bumping and all those, you know, good things, boom, boom, with the big bass. And we drive super fast, and he would always, you know, slam his hand on the dashboard and say, oh, this car sucks, you know? And I had no car, so I thought his car was amazing, and it really was amazing, but he didn't buy it, and he was one of my best friends, totally loved him, total stud guy, but he didn't appreciate it because it was handed to him. So today, one of the reasons that I had you do this is I wanted you to earn this method. So notice here that we are skipping section 5.4. What the book has you do is they have you do an entire section just doing the trial and error method, and then they teach you the better method and have you do another section, section 5.4, using the better method. I'm not going to make you do that, okay? We're going to skip section 5.4, so there'll be no 5.4 homework. Say yay!
Yay!
Yeah, see, we got our background supporters there for you. And we're just going to do 5.3, and I'm going to teach you the better method, and I'm not going to make you work really, really hard to earn the keys to the Porsche, okay? But I do want you to appreciate this method. So that's why we took 10 minutes today. So if you're like, man, I really didn't appreciate that last 10, 15 minutes of lecture, Brother Rich. Well, good, because that means that, you know, it was painful enough that you earned the keys to the better method. So we're going to pause for a second. Go ahead, ladies and gentlemen. All right, welcome back. So here are the keys to the Porsche right here. Here's the Porsche. This is method 4. Okay, this is the problem we just did. What I want you to do is I want you to pause your videos at home, and I want you to write all of this down and then rejoin us. Before you do, I just want to remind you that you want to have your 5 methods of factoring, the type of polynomial they're done to, off to the side so you can reference that. Every day that we get together, I'll have you rewrite this so you have this memorized for the test. I'm going to erase all this, give us more board space to work with. Go ahead and pause. Okay, so we just did this problem the last 15 minutes using trial and error method. Now we're going to use this method, all right? This is method 4, the ax squared plus bx plus c method, where a does not equal 1. Jordan, Hallie, will you check? Can we see all of this in the camera?
Yes.
All right, cool. All right, so it says put the tri, meaning the trinomial, in ax squared plus bx plus c order, in other words, descending order. So I'll ask you, is this in descending order? Yes, it is. Okay, yes, Jordan says yes. It is in descending order. And the reason it's in descending order is because you have degree 2, degree 1, and degree 0, because there is no variable there. And so step number 1 is taken care of. Okay, what does A equal? Again, what does A equal?
4.
Good. And what does C equal?
Negative 17.
No, that's what B equals. What does C equal?
15.
15. Good. And it's okay to make mistakes. Jordan actually brings up a good point. That's where we have to be really cognizant of what we're doing in this method. Because in the past we've been dealing with B and C, but now we're dealing with A times C. And A times C, we're going to take 4 times 15, and that equals 60. And again, I actually want you to make a chart. So it's going to be A and C, and this is going to be B. And so this is a little chart you're going to make every single time. Okay, so here we go. What does B equal, Jordan? B.
60?
No, B equals negative 17, that middle term right there. Good try, that's all right, man, I'm loving it, okay? So A times C, everybody, equals 60. B is the middle term at negative 17. Okay, now I need to find things when multiplied together makes 60, when added together makes 17. So I got to start looking at my times tables, okay? You guys know anything when multiplied together makes 60?
30 and 2.
30 and 2, Hallie says. Absolutely. Now when we add those together, it makes 32. And by the way, we need it to be a negative number, so what if we have negative 30 and negative 2? So we're always going to do two negatives here because the two negatives will make a positive, and that make negative 32. Now I need that number to be different, okay? So what are some other factors? Because we got to find 2 and multiply together make 60, but when add together make 17, negative 17. What are the times?
20 times 3.
Okay, so we try 20 times 3, they say. So negative 20 and negative 3. But when we add those together, we get negative 23. So we're getting closer to 17, so we're going to need to shrink that gap. Now notice what's happening, because we're going to teach something interesting here. Notice what's happening, okay? These two numbers, okay, were big and small, and then we brought, these two numbers lie in between this. 3 lies in between, 30 and 2, 20 lies in between, 30 and 2. So we're narrowing the gap and we're getting closer. So we're going to narrow the gap even more. What are 2 factors between 20 and 3 that make 60? Okay? Go ahead.
Negative 12 and negative 5.
Wow, Jordan knows his 12s. I'm super impressed. 12 and 5. Negative 12 and negative 5 definitely, when multiplied together, make positive 60, but when added together, make negative 17. And so that constitutes our magic pair. Come here, Jordan. Show them what you just did, man. Show them. Come on, we gotta see it, man. Yeah. All right, good job. He's giving the flex. He's giving you guys the flex. That's good. Okay. So this is the magic pair. All right. All right. Now our work is not done. In method 3, it was like, ooh, woohoo! You know, we get to put a parentheses and a parentheses, and, you know, put a 4x and an x, and a negative 12 and a negative 5. Remember, this was the answer we came up with trial and error, so that's not our answer. So that's not going to work, okay? So our work here is not done yet, okay? Our work here is not done yet. Check it out. Next step. Now, this step is so important, and people don't get it. So right now, drop your pens, drop your pencils. Do not be taking notes right now. I want you to watch and learn, okay? We need to come back to the original problem, 4x squared minus 17x plus 15. And we need to break bx into 2 terms based on the magic pair, which means that we're going to call this negative 12x and negative 5x. Think about that for just a second. Negative 12x minus 5x, when brought together, makes negative 17x. Do you agree that these two things and that one thing are the same? Yes, absolutely, they are the same. And then you drop down the other terms, 4x squared and plus 15. And now I'm going to ask you something else. And again, please, at home, don't take notes right now. Drop those pens, drop those pencils, and pay attention to this. Are these two polynomials the same? Remember, math is the manipulation of numbers to look different but remain the same. Okay? Are these two polynomials the same? Absolutely, because when we combine these two, because they are combinable, they make negative 17x, and so these are the same. Now, how many terms do you have right here? 1, 2, 3, 4 terms. And what do we do? Because I told you to write all the methods of factoring and have them off to the side. What do we do when we have 4 terms? We factor by grouping. And grouping rhymes with, say it.
Pooping.
Yeah! It rhymes with pooping. And they know that too. That's good. They've learned that. If they haven't learned anything, they've learned that. You know, I don't know what to tell you about that. Okay, check it out. So, it says here, you now have 4 terms. Factor by
Grouping.
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 Yes. Which rhymes with
Pooping.
pooping. Good job. All right, so check it out. We take 4x squared minus 12x. We put that into parentheses. We always put plus here. The sign before this term goes with it, negative 5x plus 15. This was part of your homework for section 5.1. Okay? Now, we factor out a common factor out of this binomial. We have a 4 and an x. So we take 4x out, so we'll put this over 4x, put this over 4x, and we get x minus 3. Okay? What's my common factor here? Now, Jordan, what is it?
3.
3? No, in this one we have a 5x and a 15. They're both divisible by 5. Okay, they're both divisible by 5. Now check this out. Okay, this is a negative and this is a positive. This is a positive and a negative. So not only should we factor out a 5, but we should factor out a negative 5. Totally. Okay, so we're going to factor out a negative 5. And if you're back at home and you're saying, why? Don't. Okay, let's divide this by 5 and divide this by 5. Okay, and we'll factor out a 5, so we'll have plus 5, and then we'll have negative x and plus 3. Okay, are these two parentheses the same? No, they're not. But if we factor out a negative 5, okay, so we change this back to a negative, then this will be negative or negative makes a positive x because the 5's canceled, and 15 divided by negative 5 makes negative 3. Now the parentheses are the same. Now check this out. We said the last time that we met that we're going to take our common parentheses and put it here, and what's left over, 4x and negative 5, go there, and look at that. There's our answer. And without using trial and error, we can arrive at the answer methodically, one step at a time. Okay, I want you to pause, and I want you to take notes, and we'll come back. Go ahead and pause. All right, we're back. Jordan, my son, when we got to that answer, he was like, whoa, that's magical. Amazing. Whoa, 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 it's magic. So, he liked that, and that's kind of cool, that what we did with trial and error, we can do with this method. So this is a really awesome method, but sometimes people don't appreciate this method if they've never used trial and error because it is a lot of work. And so in your homework last time, method 3, I told you pretty easy. This is our hardest assignment, in my opinion, maybe all semester. Maybe outside of the word problem assignment back in chapter 2. And so I asked you to bear down. Okay, this is your last really tough assignment this semester, but it's going to take some time. I don't think it's hard to accomplish in terms of doing the math, but you got to be thorough and organized, and you got to endure. You know, you got a chunk of change to come up with tonight, okay, or whenever you do this assignment. So I want to show you guys something interesting about this really quick, and then we're going to do another problem. So for some of you, you're going to get lost right now, but I want to help you find the magic pair faster. Because sometimes when you multiply A times C, you get a really fetching big number. And things that you can do in your head like we did here, you're not going to be able to do. And I want to help you whittle it down. Okay? So the thing I want to share with you is this. When you multiply A times C, okay? Go ahead and pause for just a second. Okay, one of the reasons I had Hallie pause just a second ago is just to try to make things efficient. I just wrote everything down that I was going to tell you so that you can see this and you don't have to watch me write it. What I want you to do is I want you to imagine this problem that we just did, and I want you to notice that we really start off with two numbers when multiplied together do make 60. So go ahead and use them. Say 4 and 15. 4 times 15 does make 60. When added together, it makes 19. And we talked about this, and I need everyone to pay attention. We need this to be a negative and a negative to make that a positive, and then to make this a negative. But then I want you to look, it says right here, look at B. So when you multiply A and C, add them together first. Make them the first pair that you use on this chart. So they'd be right up here, okay? And then look at what they make when you add them together. Look at their sum. Does your sum need to be smaller or bigger? Now, I need you to hear this, okay? Does your sum need to be bigger or smaller? And one thing I want you to understand here is I want you to forget about negatives when you answer this question, okay? You can't forget about negatives when dealing with this. A negative and negative make a positive, and that negative make this a negative. But when I'm asking the question, does this number need to be bigger or smaller, forget about negatives. So you need 19 to become 17. So Hallie, do you need this to be bigger or smaller?
Smaller.
Absolutely. Hallie says smaller. okay? So if Hallie understands this, I know you guys can get this at home as well, okay? That number 19 needs to be smaller. What I'm sharing with you is that is going to reveal something. It means that the magic pair lies in between A and C. Now I want you to think about that. Between the numbers 4 and 15, okay? Between the numbers 4 and 15, all right? Now, this is really cool. Check it out. The numbers that exist before 4 are 1, 2, and 3. And forgive me, I'm going to write those. And then after 15 are 16, 17, 18, blah, 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 right? All the way to the number 60. And what I'm telling you is your magic pair lies in between these, so all of these are no longer options. So when you came up with the idea of 3 and 20, 3 and 20, do those lie inside or outside of 4 and 15?
Outside.
Outside. And we said, you know, our magic pair is going to lie in between. So 3 and 20 become non-factors. How about 2 and 30? Did those lie outside or in between?
Outside.
Outside, okay? But notice the pair here. 5 and 12. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That pair lies in between. So it proves this to be true. So we're going to do another problem. We're going to use this knowledge and this process here, okay? All right, go ahead and pause. All right, we're back. So the second problem that you were asked to do for your homework in section 5.2, but you couldn't do it, was this one. First thing we do, we look at all of our options. We check for a common factor, even number, odd number, even number, so they're not divisible by 2, x, but there is no x. You check for a common factor, you do not have one, okay? And then, can you factor this by grouping? No, because you have 3 terms. And so you're going to go ahead and you're going to multiply A times C. Now, Jordan, I need your help here. Remember, A, B, and C. So what's A, Jordan?
18.
And what's C?
Negative 10.
Good. Which when multiplied together make negative 180. And if you make a chart, just like you do here, B equals, what's B equal?
Negative 3.
Beautiful. Okay, so we got this down. Now, here's the deal. Everybody, we're going to use this knowledge here to find the magic pair. Okay? To find the magic pair. So I need 2 numbers to multiply together make negative 180, when add together make negative 3. But I don't need to think real hard because I already have 2 numbers. There's 18 and 10. Now listen well. I need the bigger number to be negative, switching sides with it, because when add together I need this to be a negative number. Now, do you get that? I need negative 18 times 10 to make negative 180. When add together I need it to make negative 3. Okay? So I add these 2 together, I get negative 8, I switch the negative over here, because if I did 18 and negative 10, look at it. I would get positive 8, and I need a negative number. So that's why I had to switch the bigger number to be negative, okay? Now, let's think about this for a second, okay? Now we're going to forget about the negatives. Do I need this number to be smaller or bigger? You two, shout it out. 1, 2, 3.
Smaller.
Smaller.
Bigger. Smaller.
Smaller. Okay, 8 needs to become 3. So I need my number to be smaller, okay? Now check it out. That means that my magic pair lies in between 18 and 10. So I need you guys to understand the magic behind this. Between all the numbers between 1 and 180, all the options of factors that exist between 1 and 80, I'm telling you that between 10 and 18 lies my magic pair. So nothing from here to here and nothing from here to here exists. And the only numbers that exist between those are 11, 12, 13, 14, 15, 16, and 17. So I'm going to have you guys at home pause right now because I'm telling you, 2 of these numbers are going to be the magic pair. And the reason we know that is because this number needs to be smaller, and if your number needs to be smaller, then the magic pair lies in between A and C, which were 10 and 18. Okay? So, we're going to pretend pause. Okay? What did you get? Okay? Well, let's think about this for just a second. You guys, did you try some numbers? Did you try a few? You have a calculator, and you can use that calculator anytime you want. Okay? So, check it out. Did you try 11? I wouldn't have tried it. It's a prime number. It's probably not going to work. I would have tried numbers like 12. I would have tried that. I would have been interested in trying 15. And I'll tell you why. Because a number that ends in 0 is divisible by 5 or 10, and 15 is divisible by 5. Well, what's interesting is if we take 12, you guys got a calculator? Multiply 12 and 15. What do you get, Jordan?
Okay, you said
12 times 15. What do you get?
180.
180. And if you make 12 times negative 15, that makes negative 180. When added together, makes negative 3, which means that is your magic pair, okay? So, are we done with this problem? Not yet. Remember, we now need to use the magic pair to break bx up into 2 terms, okay? So we kind of run out of board space here. And I want to leave this process on the board, and I kind of want to leave that process on the board too. But I'm going to have you guys write this down right now. So I'm going to pause in just a second. I want you to write all this down. And I want you to keep it on a note next to you so that we can keep using this on the next examples. Go ahead and pause, Hallie. Okay, so now we take 18x squared minus 3x minus 10, and we're going to break bx into 2 terms based on the magic pair, okay, which is going to be 12x minus 15x, okay? And then this is going to drop down and become 18x squared. This is a positive because it's a positive 12x, positive 12. And this is going to be minus 10, and these 4 terms and these 3 terms are the same because when you add this it makes negative 3x. But now you can take this and say, hey, I have 18x squared plus 12x in a parenthesis. I'm going to factor this by grouping because I have 4 terms. That's what we tell you to do right here. You now have 4 terms, factor by grouping. Okay, and then I have plus negative 15x, okay, minus 10. That's a 15. Let's write that better. Okay, 15x minus 10. All right, always a plus in between, sign before the term goes with it. Common factor here, both these numbers are divisible by 6, both of them are divisible by x. We'll put this over 6x, put this over 6x. We get 3x plus 2, okay? We need this to be 3x plus 2. We need both these to be positive over here for these to be the same. So we're not going to just factor out a positive, we're going to factor out a negative. And they're both divisible by 5, so we're going to factor out a negative 5, divide this by negative 5, divide this by negative 5, and indeed we get 3x plus 2. Whoa, it's magic. The parentheses are the same. Okay, and we talked about, let's put our common parentheses here. Let's put what's left over here. We switched that up after our lecture last time. Okay, here's what's cool. Let's go ahead and multiply this out, everybody. 6x times 3x makes 18x squared. 6x times 2 makes plus 12x. Negative 5 times 3x makes negative 15x. Negative 5 times 2 makes negative 10. When you combine these together, you get negative 3x, so you have 18x squared minus 3x minus 10. Whoa, it's magic. This and this are the same. And this, do you have to do this part here? No, that was just checking your answer. But there is your answer to that problem. Okay? All right, what I want you guys to do, all right, again, make sure you have all of this in your notes, and make sure the thing about whether your magic pair needs to be in the middle, lies in between, or lies outside of the magic pair, lies outside of A and C, okay, we're going to reference that regularly, so have that written by you, okay, so we're going to go ahead and pause. Okay, guys, on the count of 3, I want you to yell woo as loud as you can. And you at home too. 1, 2, 3. Woo! Okay, I just want you to wake up. Because this stuff, you know, it can kind of get to you. Okay, you're at home, you're playing ISO ball, right? Yeah, and all by yourself in the world of confinement and, yeah, and COVID-19. Check it out. This is a huge problem. By the way, the 2 problems that you did were number 4 and number 16. From section 5.3. Your homework tonight, 5.3, 1 through 75 odd. I'm going to do this one, number 27, with you. This is a nasty problem. It's big. First thing we do in every problem, check for a common factor. Okay, so we're going with our cancer doctor thing, getting all the cancer out of our patients. So 35 is divisible by 5 and 7. That is not divisible by 5. 57 is a prime number. I know that because I'm the math teacher, but the other thing is this is not divisible by 5, and 7 does not go into 44. So we don't have a numerical common factor, x, no x, but we had to check, okay? And then the next method is factoring by grouping, but we only have 3 terms. A does not equal 1, so method 3 is not our option. Method 4 becomes our option. And here's our beautiful steps to method 4 again. We're going to put the trinomial in descending order. We check this. Is it in descending order? It is, absolutely, because we have x squared, x to the first, and there is no x, so that's x to the 0 ultimately. So it is in descending order. Step number 1 is already done for us. So we're going to multiply A times C, this little chart right here. And A times C, Jordan, what's A?
35.
And what is C?
Negative 44.
Negative 44. How about you multiply those on a calculator? It's a big, fetching number. You guys multiply it on a calculator at home, see if we're doing our calculations correct. 35 times negative 44, what do you get, Jordan?
Negative 1,540.
Negative 1,540. Go ahead and do it again on your calculator just to make sure that we got it right so we're not doing the wrong problem. That would suck. Okay?
Yep, it's right.
Good job. And that's one of the things we teach you guys all the time. If you're going to do something on a calculator, always do it twice. Make sure your thumbs weren't messing it up, okay? What does B equal in this polynomial? What does B equal?
Negative 57.
Beautiful. Negative 57. Now look at the size of that number. This whole scheme about finding the magic pair becomes really, really important right now. So we're going to take, so listen, if you're like, oh my gosh, I don't know two numbers when multiplied together make negative 1,540. Yes, you do. They're right there. They're always there. It's A and C, okay? So we take 35 and we take negative 44 and we say, yep, that makes negative 1540. And when we add it together, it makes negative 9. Now, Hallie and Jordan, I want you to look at this. Okay? If I forget about the negatives, okay, 57 and 9, I need this number to be bigger or smaller?
Bigger!
Absolutely, okay? And we said if we need our number to be bigger, okay, then that means the magic pair, and you guys should be referring to your notes that you wrote off to the side, your magic pair lies in between or outside of A and C, okay? So we have 1 all the way to 1,540. And here we have 35 and 44. Does the magic pair, if this needs to be bigger, our magic pair lies in between or outside of these?
Outside.
It's outside, that's right. And so these numbers are out. But what I want you to know is that there is the magic pair. One number lies between 1 and 35, and one lies between 44 and 1540. That's what the magic pair is. So there's a number between 1 and basically 34, because 35 is out, okay? Because we've already tried 35 and it doesn't work. So there's a number between 1 and 34 that is one of the magic pair, okay? Now, I like, again, to look at the nature of my number. This number ends in a 0, so it's divisible by 10. And the thing is, the other thing is that 20, 40, 60, 80, double zeros means divisible by 20, okay? So, do you want to try, so I'm telling you right now that I would imagine that numbers that would be good possibilities here are 10, 15, 20, maybe 25, but that's not going to be divisible by 25 because 25 would be 25, 50, 75, double zero. That one's out. So which one would you guys like to try? 10, 15, or 20?
15.
15, okay. So go ahead, Jordan, and do 1,540 and divide it by 15. 1,540 and divide it by 15. Does 15 go into it? Or is it a decimal?
It's a decimal.
Okay, so back at home, everybody, if it's a decimal, it's not an option. So 15 is out. Okay? So what about 10 and 20? And why am I picking these numbers? Because they're numbers that end in 0 just like 1540 ends in 0. Okay? So anything between 1 and 34 is an option. 17, 19, 13, 14, all these different numbers. But I want to try the ones that will end with the 0 and 5. What other number would you like to try?
10.
10. Okay, so let's go ahead and let's put 10 in. Now 10 is going to go in 154 times, isn't it? Is that right?
Yes.
Okay, and the difference between 10 and 154, so we'd say negative this, is going to be negative 144. So does that make our magic pair, yes or no?
No.
No. So that leaves what?
20.
Okay, so now put 20 in. Do 1540 divided by 20. And you get 77.
77.
Yep. And so look at this. 20 and negative 77, when you add those together, make negative 57, and voila, there's your magic pair, okay? And you think about that, 77's over here, 20's over here, your magic pair lied outside of 35 and 44. And then you take this and you say, hey, 35x squared minus 57x minus 44. We're going to break this up into two terms. We're going to call that 20x and negative 77x. We're going to drop down the negative 44. We're going to drop down the 35x squared. This is a plus because that's positive 20x over here. Okay, and then we're going to, put a parentheses around these, put a parentheses around these, put a plus in between. I took a little shortcut there. Did you notice that? Always a plus in between though, and this negative goes with it. What's my common factor here? Everything's divisible by 5 and x. We put this over 5x. We put this over 5x. We get 7x plus 4. Yes? 5 times 4 is 20. The x's cancel out. And my common factor here, again, I need these two things to be positive. Right now these two are negative, so I'm going to factor out a negative. 11 goes into both these numbers, so it's going to be negative 11. Put this over negative 11, put this over negative 11, and I'm going to get 7x plus 4. My common parentheses is 7x plus 4. The leftovers are 5x minus 11, and that is the answer to this problem, okay? So what was a really gnarly problem, we can find the answer to, okay? I'm going to give you guys one to do at home. Let's go ahead and pause. All right, guys, we're back. I'm going to give you one that you could probably do all of it with your times table skills, but I'm going to give you one here that I want you to do. In a second, I'm going to have you pause it, follow all your steps, okay? But one hint I want to give you, make sure that you look at all of your factoring methods to make sure that you're checking for everything you should, okay? Go ahead. Yeah. Okay, so I asked you to factor this, and the first thing you do is you got to be a cancer doctor. You got to look at all your methods of factoring, so you check for a common factor. Look at the numbers 6, 4, 10. Is there a common factor amongst those three numbers? Yes, good job. Allie, say it.
2.
Very good. It is 2. They're all divisible by 2. Is there a common factor amongst the variables? X to the third, x squared, x. Yes, they all have an x, and the lowest degree of that common variable is x. So we got to put this over 2x, this over 2x, and this over 2x. And we get 3x squared plus 2x minus 5, okay? Now, listen, if you forgot to pull that out, you're just right now going, oh, fetch, and I understand, but you've always got to look for a common factor. So many of the problems don't have them, but all of them have the potential. So you got to get in a habit of looking every time, because they sneak up on you. About 1 every 10, 12 problems, you'll have a common factor. And you think about that, that's a couple every test, because you have 25 problems in a test. So you know it's going to happen on the test. Okay, so if you didn't get this, figure that out, and now let's have you pause again and just do this with method number 4. Okay? All right, so the 2x is going to come on down to the answer. All right? And Jordan, what does A equal?
3.
And C equal?
Negative 5.
And 3 times negative 5 makes negative 15. What does B equal?
2.
2. Good. Okay? Now this is kind of cool, people. Look at this. I told you, use this A and C to start things off. 3 and negative 5 make negative 2. So let's flip that. Negative 3 and positive 5, that still makes negative 15, but now it adds together to make 2. You had really not a lot of work to do because A and C ended up being right there with your magic pair, just changing up the negatives, okay? So now we're going to take this, we're going to come over here, we're going to take 3x squared plus 2x minus 5, and we're going to break this bx up into two terms based on what we just found here. Oh, that's a wonderful sound. Hallie's making faces. We should do some scratching. All right, check it out. So we're going to take negative 3x and positive 5x. Why? Because negative 3 and 5, and we're going to bring the x's with them. So when we add that together, it makes 2x. Drop down the negative 5. Drop down the 3x squared. You have 4 terms. Factor this by grouping, put the parentheses around it, put the plus in the middle. Common factor here is 3x. Put this over 3x, put this over 3x, and I get x minus 1. And now I pull out a 5, and I put this over 5, this over 5, and I get x minus 1, and the parentheses are the same. We didn't have to pull out a negative of this one to make them the same. My common parentheses is x minus 1. The leftovers, 3x and 5, go here, 3x plus 5, and then the 2x is brought over because we pulled it out in the beginning. Okay, now, I want everybody to watch something, okay? Really, really, really important. What if, when you did this, okay, instead of writing -3 and 5, you wrote 5 and -3? 5 and -3 make -15, when add together make 2. They're the same thing, they're just in a different order. But if you wrote them in that order, you would probably write them in this order here as well, okay? So what if you have 3x squared plus 5x minus 3x minus 5, okay? Check it out. Let's look at this. First of all, 5x minus 3x does make 2x, so these are the same. Let's go ahead and factor this, just like we did it this way, and see if we get the same answer, okay? If I take 3x squared plus 5x, put it in parentheses, put a plus, negative 3x minus 5, my common factor here is x, so I'll put this over x, put this over x, and I get 3x plus 5. My common factor here, I need this parentheses and this parentheses to be the same. They are really close, but I got to factor out a negative, okay? So I got to factor out a -1, so I put this over -1, I put this over -1, and I get 3x plus 5. Now my common parentheses is going to be 3x plus 5. The leftovers are x and -1, and I get the exact same answer. So what I wanted you to understand is, it doesn't matter what order you put these in here and what order you put them in here. As long as they make the middle term, you will end up with the same answer. Okay? Let's pause and do one more. All right, one more for you guys to practice at home. Okay? I want you to get some practice doing does my magic pair lie in the middle or lie in between or lie outside of A and C? So I'm going to go ahead and pretend pause, right? And let you do this. So, okay, we're back. Yeah, woohoo! Okay, check it out. Okay, first thing we do is we check for a common fetcher. Even number, divisible by 2. Not divisible by 2. Even though those are both divisible by 2, if that's not, we do not have a common numerical. No M. N, no N. You checked, you do not have a common fetcher, but you tried, and you don't have it, okay? You don't have 4 terms, you cannot factor by grouping. This does not equal 1, so you can't use method 3, so we're coming to our beautiful method 4 here, okay? Jordan, what does A equal?
12.
Hallie, what does C equal?
20.
How about -20? Close. Always bring the sign with it. That's a good thing for everyone to remember at home, too. Okay? We multiply these two, okay? Do you know what the answer is, Jordan?
It is 240.
Very good.
Negative
-240. Again, remember your negatives. And B equals, what does B equal?
B equals 0.
No. What's in front of this term?
-1.
-1. Very good, very good. And that's another good thing to remember, okay? If that's just a negative, it's a -1, okay? Not 0, right? Good. Okay, so we take these two numbers right here, 12 and -20, because those are the ones we're going to start with, so we don't have to think too hard. We add them together, we get -8. Now we ignore the negatives, okay? So I need 8 to be bigger, or I need 8 to be smaller. You two say it on 3. 1, 2, 3.
Smaller!
Good job, we need it to be smaller. Now we talked about the magic pair, okay? If you need it to be smaller, then it lies outside or in between?
In between.
Very good. It lies in between A and C. So we think about this. A and C are 12 and 20, and we have numbers all the way from 1 to 12, all the way to 240. And what we're saying is, our magic pair is going to lie in between. So the only numbers in between, so like the 1 through 12, 23 through 40, none of that works. The only numbers in between are 13, 14, 15, 16, 17, 18, and 19. Now I want you to use your God-given gift of common sense here. I want you to look at the nature of the number 240, and I tell you, what numbers do you think won't be options? Okay, just guess. What numbers won't be options, probably? Go ahead, Sam, what do you guys think?
15.
Won't be an option?
Won't.
Well, maybe. Okay, that's one that I actually think would be an option because that ends in a 0, and things that end in a 0 are divisible by 5s and 10s. So I think 15 could be an option. I think 13 is out. I think 17's out. I think 19's out. Those are prime numbers, and they probably won't work with that. And so I think things like 14, 15, 16, and 18 are things I would try. So the very first thing I would try is I do 240 divided by 15. What do you get?
240 divided by 15 is 16.
Now look at that. There's your magic pair. 15 and 16 lie in between 12 and 20, and 15 and 16 when multiplied together make 240. Which one's got to be negative? This one does, because when added together makes a -1. Okay, you have found your magic pair. Now you're going to take this right here and you're going to say, 12m squared plus 15mn, because you're going to break this up, minus 16mn, okay, negative 20n squared. So look at this. I'm taking negative mn and I'm breaking it up into these two, because 15 minus 16 will make a -1mn. And then I'm going to factor by grouping, because I have 4 terms. 4 terms here. So I'm going to take 12m squared plus 15mn, put it into parentheses, plus negative 16mn minus 20n squared. By common factor here, okay, both these are divisible by 3.
3.
Very good. And m. So I'm going to put this over 3m. I'm going to put this over 3m. And I'm going to call this 4m plus 5n, because the m's cancel out, okay? And then over here, now look at, these two are positive, and I need this parentheses that comes down to be the same as this. These two are negative, so whenever I pull out, I've also got to pull out a negative. Very good. So I'm going to pull out a negative, so I'm going to put this over, these are both divisible by 4, so I'm going to have this over -4, and this over -4, and there's an n and an n, so I'm going to put it over this, okay? And I'm going to simplify this, and I'm going to get, wait, I'm sorry, I'm going to put the -4n here, and then what comes in here, 16 divided by 4 is 4, n's canceled, there's an m, 20 divided by 4 is 5. Negative over negative makes a +5, so we accomplished that. N squared over n is n. Look at that. Whoa, it's magic. The parentheses are the same. And so your same parentheses, 4m plus 5n, the common parentheses comes here. The leftovers, the sloppy seconds, 3m minus 4n goes right there, and you are done. All right, folks. Going to take just a second here before Hallie calls it a night, and Jordan says it's all right, okay? We are going to just encourage you, okay? This is a challenging section. I need you to put on the big boy, big girl pants. I need you to buckle up, okay? Pull up your bootstraps, whatever you want to call it, okay? This is just a hard work section. Put your heads down, one problem at a time, nail it down, okay? Get it done. If you need help, get online, get a tutor, get that help that you need. Okay, you've got 1 through 75 odd. The beauty of this is, though, we're skipping section 5-4. Okay, so put your heads down. Good luck, and I'll see you next time.